Hey everyone, thanks for joining us for this Portworx monthly demo. Really excited to have you here and excited to be with my colleague Bhavin Shah. Bhavin is stepping in for Ryan today, so there's a little bit of false advertisement on the headshot. But we were all really lucky to have Bhavin with us today. He's got an awesome demo prepared for us on disaster recovery on Kubernetes. So I don't want to steal too much of his thunder. We've got a bunch of folks that have signed up for our session today, so I'm just going to give them about 1 more minute and then we'll go and get started. All right, well, let's go ahead and get started. We've folks are still streaming in, but we can go over some of the logistics for you today. So we want this to be as interactive as possible. So use the chat and the questions panel to let us know what's on your mind. We do this for you as much as we love Portworx. It's about educating you and answering the questions that you have. So let us know, and we can incorporate those as we go through the presentation. We can do them as a Q&A at the end. Really just want to make sure you get as much as possible out of the session. What we always do on these, if you've attended one in the past, is the demo is always different, but we like to set the stage. And today, this is a newish topic to our monthly demo series on data protection. So I have some slides that I want to walk through to kind of set the foundation for what does it mean to have a Kubernetes-native data protection solution, and ultimately how Portworx fits into that. And also like just to share some customer successes we've seen with the Portworx solution, so that you can get a sense of what's possible within your own organization. And then always the highlights of demo. So Bhavin's got a great demo prepared for us, and we will do definitely Q&A at the end. But I like as much as possible to intersperse the Q&A throughout. So if I'm talking and you have a question right then, just pop it into the chat. Bhavin can answer some of those. I can read them on live, and yeah, we'll go from there. So let me share my screen and talk a little bit about Portworx, the data services platform for Kubernetes. That's the wrong screen, of course. I've got double monitors. Let's see. Should be the one. All right, Bhavin, help me out. Can you see my screen right now?
Yep, I can.
Awesome. So let's dive in. Lots to cover today. If you've been to one of these before, you've seen this slide, and the reason I keep showing it because it's such an important statement that data is the heart of everything that we do as businesses today. And if you're stuck in this perspective of thinking about stateless versus stateful, then I think that you're doing yourself a disservice because data is at the heart of modern business, and that data needs to be just as agile as the rest of your stack. The fact that you are in this session, and so maybe that last comment is more for a colleague of yours who's showing a little bit of reticence to move some of the the modern applications that require data into Kubernetes. Folks like yourself have seen that there is a new stack, a digital stack that allows us to get the most out of our data, and it revolves around technologies like containers, like Kubernetes. It involves new people and processes, things like DevOps and GitOps, and then a whole host of new data services, right? We're not running everything on our Oracle database anymore. Now we have dozens of microservices, each with their own specialized data store. Now, kind of, this is it's happening. It's mainstream. I'd go so far as to say, every large organization on the planet is already using containers and Kubernetes, and increasingly they're running those applications in production. Now, not every application in every enterprise is using containers and Kubernetes yet. Not every team is using containers and Kubernetes yet, but that's where the opportunity is to use these technologies to apply automation and allow us to kind of run applications that are not only more reliable, but can be deployed to production faster, can allow us to increase our agility to respond quicker to changing market demands. But we kind of, as we're on that journey, we get to a point where we run into some roadblocks. And disaster recovery, the topic of our demo today, is one example of that. Which is, it's not obvious how, when I'm running a distributed application on Kubernetes, like how do I move that application between locations, right? Either from just a migration perspective or a backup and recovery or a DR perspective. How do I protect my data, right? Through well understood mechanisms for traditional applications like encryption and role-based access control, but in a completely on-demand, a completely distributed, and a completely user granular, container granular level. These problems are not solved natively with Kubernetes. Kubernetes was built and architected to enable solutions like Portworx to extend Kubernetes, to provide the data management and the storage capabilities and the data protection capabilities necessary to run really any enterprise application in a modern cloud native way. And at the end of the day, what Portworx does is provide a modern data experience that cloud native applications require. What do I mean by that? Well, I mean completely API driven, right? Leveraging scale out versus scale up architectures. The ability to do everything at the container granular level, to utilize the native management capabilities of Kubernetes, but extended into the data tier. That's what you mean by a modern data experience. Customers just like you are running Portworx in production today with some very large scale, very important, the buzzword of the day is mission critical applications. Our customers are doing all of those things. And so no matter your environment, the types of applications, your industries, there's another customer that's already doing the same things that we can bring that expertise to bear on your particular application. Now, the Portworx platform is made up of a number of components. So we're going to talk specifically about the data protection capabilities today. But I think it's important to step back and say, okay, what's the environment in which these applications are running, and how does Portworx fit into that environment? Because it's one thing to provide data protection, right? But there are lots of data protection solutions on the market, right? How do those fit in with the types of applications we're running in containers on Kubernetes and in the different environments? So what makes Portworx unique is that you can use Portworx to manage in a completely consistent way, really any application that has data and is running on Kubernetes. I mentioned earlier, we've transitioned from let's put everything into an Oracle database to, let's use Elastic for search, and let's use, Kafka for streaming, and let's use Couchbase for transactions, and let's use, and the list goes on and on, Splunk for logs. As we decompose our application into microservices, we have lots of different data services that we need to operate. And yet, as operations professionals, we are not commensurately becoming experts in each of these different data services, right? So that creates a challenge for how do we enable our developers to use the best tool for the job, but still be able to provide security and data protection and high availability that we need from an SLA perspective. Well, Portworx is the way that you can do that, right? Because we provide a common tool set for managing any application. It doesn't matter what Kubernetes distribution you use, we support them all. We're going to be demoing on OpenShift today, but that doesn't mean that you can't be all in on Tanzu or all in on Amazon EKS. And frankly, you can use all of them because Portworx integrates with all of them. And we have many customers who have not made a standardization decision yet. And one of the benefits of Portworx is that they can go through the standardization process at the compute tier, but still know that their data is going to be managed consistently in all of those environments. From an infrastructure perspective, name your cloud, we work. Name your on-premises infrastructure, we work. So, we're part of Pure Storage, and we think there's a great experience to run Portworx on top of FlashArray and FlashBlade. But if you're running on top of NetApp, then we can help you there as well. If you're running on bare metal on premises, we can help you there as well. It doesn't matter what your infrastructure is. And then finally, don't think about having to start with this massive global scale project. You can get started with Portworx without ever talking to anybody, completely for free. Use this in your test dev environment. Grow as you need with Portworx. We can help you there as well. So the platform itself is made up of 6 modules, and I'm going to spend most of our time today talking about 3 of them: PX Store, PX Backup, and PX DR, because this is really kind of the heart of how we think about data protection. PX Secure has a big role to play, right, from a security perspective, but I'm thinking more about kind of availability and mitigating data loss versus kind of, typical security concerns around things like access. But just realize that everything that I'm saying about data protection, you can layer on security on top of it. It's not an either or. So data protection is, it's just essential for enterprise applications. And I was thinking, do I really need a slide to say this? But visuals are always good. And you just need data protection. It's non-negotiable, and that could be for just backup reasons. It could be for compliance reasons. It could be for SLAs around recovery. There are lots of different reasons why applications need data protection. Now the issue is that traditional backup methods and traditional data protection methods more broadly don't really work for containers. They tend to be machine focused, right? So if I migrate the machine, or I create a backup of the machine and I put it in a secondary location, I'm also going to have my application in that secondary location, because we typically, in monolithic architectures, we would run an application per server. But now we're breaking that apart. We are using containers, we're using microservices. An individual application is spread across dozens of different containers, which is spread themselves across dozens of different machines. So we need a different level of abstraction. Second, traditional data protection doesn't leverage the power of Kubernetes, both in terms of things like namespaces, where I can say set up DR for an entire namespace, and that anything in that namespace is automatically going to be protected, as opposed to protecting the infrastructure that namespace is a part of, or just setting up individual container level protection. But then if I have a dozen apps in that namespace, then I need to set it up a dozen times. And finally, there's this whole notion that this is a DevOps world. This is a self-service world. I don't want to put in a ticket and ask you to do something for me. I want to do it myself. So we always have to think about, how do we enable data protection that is not only application granular, but also self-service. If you look at the research that the analyst community is doing on this, there's a big gap in knowledge on kind of what is actually required to protect Kubernetes applications as opposed to traditional applications. And this is a survey from ESG that they recently conducted that says that 75% of IT pros wrongly believe that containers can be backed up the same way applications are backed up. Basically, okay, I'm already doing something for my VMware environment. I'm just going to do that now for my Kubernetes environment because all my containers are running on my VMs, right? It doesn't work that way. The reason, well, actually, let me take a different track. I want to talk about the reason, but I also want to talk about Portworx as a platform. Is Kubernetes data protection for all of your applications. And I mentioned earlier that we're going to focus mainly on PX Store, not PX Storage, sorry. The branding people, which is me, will be mad at me, which is myself, for making that typo. The PX Backup and PXDR. So I'm going to talk about all of those. But the key point that I want to make is that data protection is bigger than just backup. It's bigger than just local high availability. It's bigger than just DR. You need actually potentially some element of all three of those for some apps, and potentially none of those for other applications, right? I'm talking about a test environment. And so you want to think about a menu of choices in order to protect each of your applications. And Portworx is really that Kubernetes-native data protection solution. So there are 5 what I call essential elements of a Kubernetes-native data protection solution, and that can be your backup solution, that can be your DR solution, that can even be your kind of local high availability solution. And when I say local, I mean all, up to and including across availability zones. You want to be able to architect your application to take advantage of these capabilities. So the first is container granularity, right? We have to get away from protecting servers and thinking that that's giving us application granular protection, right? It just doesn't work that way when we're working with distributed applications that are running across a host of machines. The second point is you need to be able to take advantage of the Kubernetes native management capabilities so that you're not forcing your users to use multiple systems in order to protect, for instance, their Kubernetes deployment, right? I want to use kubectl, and how do I do that? And how do I have a Kubernetes namespace native experience? And okay, so even if I can use kubectl, I have 100 different pods that are running in this namespace. Can I just protect them all? You want to be able to do that at a namespace granular level as opposed to an individual object level. The third point is application consistency. And if you think back to a few slides ago where we looked at what are the data services that are powering modern applications, well, they're distributed data services, right? It's Cassandra, and it's Kafka, and it's Elk, and it's Couchbase, right? These are not monolithic, scale up data services. They run across a host of servers themselves. And so when I take a backup of one of those, I need to make sure that I'm backing it up in a way that I can actually restore from, right? It's not a Kubernetes backup is not just a collection of point-in-time snapshots that we hope work, right? This is a distributed system. We need to capture the distributed state, which means that we need to, quiesce the database. We need to flush pending writes to disk. We need to take our distributed snapshot, then we need to unlock everything, so we can take writes again. And sometimes we have to run commands to rebalance and resync, right? That's table stakes for a Kubernetes native solution that Portworx provides. And you really have to think about that, because otherwise your developers are going to be in for a kind of a rude awakening. The next point, and this will factor in a lot into Bobin's demo, is that you need to think about protecting not just your data, but also your application configuration. Just data is not enough. And likewise, I would say just app config is not enough, right? There are solutions on the market that focus on protecting your Kubernetes configuration, and that's really, really important. But without the data, right, you're still only halfway there, maybe not even halfway. You want to capture both of them, and this is one of the things that Portworx does, is we take your data and all of your Kubernetes objects that define how your distributed application works together as a single unit, and we keep it as what you could think of as a single object. Now, when it comes to restore, you can granularly pick off pieces that you want to restore, but that application has been protected holistically, and this helps with recovery. It helps with kind of the efficiency of those backups, and is absolutely critical for Kubernetes native protection. And the final part is, modern applications run across clouds. So if you have a great solution for on-prem, well, it's just a matter of time before you say, okay, how do I solve this in the cloud? If you've got a great solution for AWS, but it's very AWS native, then as soon as you move into Azure or Google, you're going to have to recreate that solution. So you want something that from the beginning is optimized for a multi-cloud and multi-site world. You can think about this in terms of tiers. So, data protection, it's, there's an HA angle and there's a backup angle and there's a DR angle. And you really want to be able to apply these different levels of protection on an app by app basis. If you're like many of our customers, you're building a Kubernetes platform internally to run lots of different types of applications. And oftentimes you are not the one who builds the app to begin with. And you're not the one that defines the application requirements, right? Just the way that, if I'm running an application on Amazon, Amazon doesn't know what my business requirements are for this application. They provide a menu of options that allow me to architect that application. Well, your customers are in the same way, or in the same boat. You want to provide them with a menu of options that allow them to run an application on your platform, regardless of how mission critical, regardless of the SLAs that they have in place with their own counterparty, and that on an app by app basis, they can decide to enable backup and restore or enable DR that's consistent and tuned for various levels of RPO and RTO. This is one of the things that is the implication of being container granular and Kubernetes native, which is that we can apply these levels of data protection at the specific application level, not at the infrastructure level. I think one more slide, maybe two, to overpromise and underdeliver. The reverse of that. I want to underpromise and overdeliver. Hopefully that's not a Freudian slip from your perspective on this webinar so far. I want to show you an example of kind of what's possible from a customer perspective, given this kind of theoretical foundation that I just talked about. Well, here's an example of a customer who faced a very real problem. They were having a lot of success onboarding applications into a modern Kubernetes-driven environment. And they were seeing a lot more agility, a lot more speed to market for those types of applications. And they said, great, what's next? What else can we put on this platform and get those similar benefits? Well, there came a point when the incremental app that they wanted to move into Kubernetes had a DR requirement. And it was not only a DR requirement, but it was a very stringent DR requirement for 0 RPO and very fast failover in the event of a complete data center outage. And they kind of scratched their head and they talked to Portworx. And ultimately, the way that they solved this was with Portworx PXDR. This is PXDR, this goes back a number of years, was actually co-developed with RBC. And it was really built from the ground up to say, okay, what does data protection look like in a completely Kubernetes native environment, where it needs to be driven on an app by app basis, where it needs to be self-service, where the levels of RPO and RTO are just as stringent for traditional applications, but need to be completely managed via API and completely automated. That's what we ended up building with RBC. And not every customer starts there, but you can see how if this type of banking application with all of the intended concerns of high risk of failure, regulatory issues, security issues, if that type of application can move over to Kubernetes, right? Well, then what type of app can't move over into Kubernetes? And that's why I like to share this story. So I'm going to come back to this slide at the end because I want to show you how to get started. But I'm going to turn it over now to Bhavin to present. So I'm going to stop sharing, Bhavin. You can take it over. And just a reminder, start popping your questions into the chat, into the questions panel. We really want to make this interactive. So Bhavin's got a great demo for us on PXDR. And I'll answer questions as he goes through, and then we'll do some Q&A at the end. So over to you, Bhavin.
Awesome. Thanks, Michael. Hopefully everyone can see my screen. And It's readable enough. Okay, thanks.
Yeah, that's really good.
Perfect. So as part of this demo, we want to talk about disaster recovery with Kubernetes, and specifically for the purposes of this demo, we are talking about asynchronous DR. So PXDR can very well support synchronous replication and synchronous DR. As Michael already alluded, we have a customer who's using it in production. But for the demo, we wanted to try a different use case. So we have a couple of OpenShift clusters deployed in AWS. We have one running in the US East 2 region, and then the other one is running in US West 2 region. We have Portworx or PX store running, and we already have a disaster recovery relationship established between them. So what does that mean? So we have a common set of shared object store credentials, and then which are used to create a cluster pair object. So cluster pair allows basically resources or Kubernetes objects from one cluster to be deployed on a second Kubernetes cluster. So all the validation work from a security perspective is handled by creating a cluster pair. And then the next step is just creating a schedule policy. So since this is asynchronous DR, RPO is not 0, but then we can still go as low as 1 minute, or you can have a schedule policy that defines intervals in terms of how many minutes and you want the snapshot or a copy of your application to be moved from one location or one Kubernetes cluster to another. You can go on a daily schedule, a weekly schedule, or even a monthly schedule based on your application SLAs and how you want to do it. So as part of this demo, what we do is we already have a schedule policy created in both the clusters. It's a 5-minute schedule policy. So once we start a migration schedule, it will start copying data over every 5-minute intervals. So let me go to my terminals, and we'll deploy an application, and we'll start a fresh migration schedule to show you how the migration actually takes place. So on the left here on the white screen, we have the East cluster connected. So if I just do a get nodes, you'll see that we have a 3 master, 3 worker OpenShift cluster running in AWS US East 2 region. And then similarly, if we do the same command on the terminal on the right, you will see that you have 3 masters, 3 workers running in the US West 2 region. Again, they are both running Kubernetes version 1.20, OpenShift version 4.6, I guess. But now that we have our clusters ready to go, let's deploy an application. So we have a simple application, which is a UI based application to give you a feel of how making sure that we can prove that the application has been successfully restored. So we'll deploy a Postgres database, which is part of the application itself. And everything is deployed in a single namespace. So PXDR works at a namespace level, and it copies everything from the application configuration to the persistent volumes that are running in the same namespace, and then copies it over to your secondary cluster or your disaster recovery or DR cluster. So we can do a get pods on that namespace. It's just called a demo namespace, and you will see that Postgres is already up and running. We'll use another YAML file that has like a front end interface to the application or for the application, and we can see that, okay, both of those are running. We can do get PVC on the same namespace, and we'll see we have a 10 gig volume which stores the data in a Postgres database. If we go to the OpenShift UI, this is, again, the way I have organized this is the left tab is the East region, the right tab is the West region. So if you look at the East region, we have a couple of deployments that we just created with one pod or one replica each. So we can go to the pods, and it says it is running. We can scroll and see, okay, we have service objects created. And then if we go into the storage tab, we'll see that we have a 10 gig persistent volume running as well. So let's navigate to the user interface for this application. Hopefully the app is all up and running by now. And the application is running on port 8080. So it takes a few seconds for the application to come online. Let's go back to the terminal and let me show you the schedule policy while the application loads. So whenever you install pxdr, you have a bunch of default policies or default schedule policies that are available for you to use. But you as the operator have full flexibility to create your own schedule policies. So I've created a schedule policy, as we discussed earlier, for copying the application over at every 5-minute interval. And that's ready to be used by my migrations or migration schedules. If you see, we have our application up and running. So this is just a simple application where we'll add a few data points. So it basically captures the pixels that are wherever I'm putting a Kubernetes logo on top. So as you can see, we have generated 6 data points in the application. So let's go back to the terminal and we'll create a migration schedule. So let me show you what's included in creating that migration schedule. So we give it a name, we point it to a namespace, we point it to the cluster pair that's created. So since my application is running in the US East region, we are using the US West region as the secondary site or the DR site. We are including all resources, not just volumes. So including all the application config, the deployment service, config map definitions, everything is being included. And then I'm pointing it to the schedule policy. So the 5-minute schedule policy that we created, this particular migration schedule will use that schedule policy. So we can, let's just go ahead and apply that file. So migration schedule is created. Let me just make this full screen so it's easier to read. We can do a store.ctl, which is again a utility that's available for anyone to use. Migration schedule. And you can see that we have a demo migration schedule with 5-minute policy, the cluster pair that we configured, and right now it's running, it's not suspended. We can do a get migration and see that the replication is in progress. So it copies over 1 volume, which is the 1 PVC that we saw in that is part of our application, and it has identified 8 different resources. So this includes a couple of services, couple of deployments, config map, PVCs, everything that's needed for the application as a whole to run successfully when it's restored on the secondary side. So let's look at a status again. Again, it took the pxdr just a few seconds to copy over the data, because again, as we just deployed the application, it didn't have much to copy over, and all 8 resources were successfully backed up. So at this point, what we can do is right now I can't let's simulate a disaster event and basically suspend the replication. 1 copy already exists on the secondary side. We'll suspend the replication, we'll delete the application just to make sure that we have simulated a disaster event. So for that, we'll just use suspend command, and then we'll suspend the migration schedule and give it the name that we used and the namespace. So this basically suspends copying over any new data, because again, if this was an actual disaster event, you don't need to do this. This is just to simulate a disaster event. We'll also delete we'll also delete the application just to make sure that we don't have any remnants sitting back. So it's sitting in a weird directory. So we'll delete the front end first. I have to specify the demo namespace. So we deleted the application. It just takes a few minutes for it to clear out the service, because it used a load balancer in AWS. So service type load balancer takes a few seconds to delete. If it's just a cluster IP or a node port, it gets deleted really quickly. Once that's done, we'll also delete the postgres YAML file that we had. And again, here it's deleting the storage class, the persistent volume claim, config map, deployment, and service. So if we do a get all on that namespace, we see that, okay, there's nothing here. Get PVC on that namespace, we'll see, okay, there's no PVC remaining. So at this point, if you are an operator who's responsible for restoring the application, all you need to do is log on to your secondary site and activate the migration, and that's it. It automatically scales up the replica. So let's go to the OpenShift interface. For the West cluster, as you can see, my application is already running. A couple of pods have already been deployed. So one for the Postgres pod, one pod is for the Kubernetes front-end service, and then we have the deployment. One interesting thing that I didn't show you earlier, which we'll cover in the failback scenario, is even before activating, it already has the deployment object created, but it doesn't have any actual running pods, just to make sure that there aren't any inconsistencies involved. Similarly, it copies over all the data, and when we create that migration schedule, we specify mode as disaster recovery. So any data or any application config that's being copied over to the secondary site is incremental. We don't copy over the whole thing over and over again. Since this is between cloud regions, obviously we want customers to save on cost for just data migration. So everything that's moved over between regions is incremental in nature. So we have our persistent volume claim created. We have our service that's up and running. So let's go to the load balancer endpoint that's created for the US West region Kubernetes cluster. And we'll see whether all the different Kubernetes logos that we had generated successfully failed over to the second site. So voila, we have all the different data points that we had included. But now let's say I'm in a scenario where I have my application running on my secondary site and I'm continuing to serve user traffic. Let's add a few more data points to this UI. But now I want to restore it. Like my primary site came back online, my primary cluster came back online, and now I want to restore my application to its original location and run it at my primary site. So for this, let's go to the West region, and we'll create the same thing. We'll create a migration schedule, and again, since I wanted to do this live, I'm creating things one at a time, but you can already have these migration schedules configured, and it's just a matter of activating and deactivating those to restore your applications. So we have a similar migration schedule defined. So it's using the same 5-minute policy. It will include all resources. The only difference here is the cluster pair. So this is to make sure that it's copying resources from the source, which is now the West region, and putting data back onto the East region. So that's why we have a different cluster pair. You can have a cluster pair for each direction. And if you have multiple applications running in multiple different namespaces in the same cluster, you can have a cluster pair for each. And you can have a migration schedule for all your different applications that are running on top of Kubernetes, or OpenShift in this case. So we'll create the migration schedule object on the West side. So this basically means if I do *ctl, if I can type, and then look at the demo again. So it will copy over the persistent volume and the 8 different objects that we had identified earlier over to the source side, or back to the East region. Let's show you a couple of other interesting things. So we added a few more data points on the application itself. This is the OpenShift interface for my West cluster. If I go back to my East cluster, right now I don't have any deployments because the replication isn't done yet. I definitely don't have any pods, and the same can be said about services as well, and persistent volumes. But once the application, once the DR job is successful and everything is completed, I'll show you what it looks like when you are just storing data at a second site without actually bringing the application online. So as you can see, our failback operation from West to East region is successful as well. If we go back to the user interface, this is the interesting thing that I missed to show during the failover process. So the deployment objects are created, but the pods aren't actually deployed. This is to make sure that you don't have any application inconsistencies. Only when you activate your migration, that's when it will deploy additional pods and bring the application online. But it already has all the Kubernetes objects that you will need. So it has the deployments. If you go to services, it has both the services already ready to go. It has the persistent volume. And again, every time some new data is generated on the west side, it will copy it over every 5 minutes onto the east side incrementally. So let's do the same thing over again. Let's suspend the application or migration here. Migration schedule. Okay, so now that we have suspended it here, what we'll do is we'll go back to the east region. Right now, if we do a get all for the demo namespace, you can see that the deployment is ready to go with 0 replicas. And then we have 2 services. So what we'll do is we'll use stockctl, activate migration, and then specify the namespace. This basically adds replicas to my deployments, or it creates those pods that were not originally deployed. So if you navigate back to the OpenShift UI, you can see now it says 1 out of 1 pods. And if I refresh this page, it should give me like, oh, it came up like a minute ago or a few seconds ago. Yeah, so it's close to 241. That's when it was created. Both the things are running right now, ready to go. Deployments are running. If we go to storage and look at persistent volumes, persistent volume was already there. And then we have our service. So now I think now is the time to see if this was a Schrodinger's DR where we don't know whether the DR worked or not, to actually making sure that the new data that was written from on the west side is now copied over to the east side. So as you can see, we are on the US East region and the load balancer endpoint for that. And we have the new data that was added to our application when it was running on the DR side, successfully being failed over to our primary location once it was back online as well. So that was like a really quick demo showing asynchronous DR, showing a failover and failback operation. I'll switch it back to Michael, and then we can handle any question and answers.
Awesome. That was really good, Bobbin. Thank you so much. I've been kind of answering Q&A questions as they've been coming in. So thanks everybody for posting those. I will, so I've got one I haven't answered yet. So let's do that one, and then I'll go and just read for everybody. I'm not actually sure if you can see other people's questions, but we'll talk through that and then keep them coming. So I'm just going to read this one. It says, when you suspend migration schedule, you actually do graceful mirror break. How fast would it be if we have hard off on one site? Would the workflow be the same for the DR site in case we expect 5 minutes of data loss? I don't fully understand the question. If you want to type it maybe a different way, I think the way to think about RPO and RTO though, and I think that probably gets to the heart of the question, is RPO is going to be based on how you're replicating your data mainly from site 1 to site 2. So what Bobbin was showing was an asynchronous, which is based on a snapshot schedule. So if you snapshot every hour, and then as soon as that snapshot happens and has been transferred, you have like an outage, then you're gonna have less than an hour of data loss, because like that happened right after the snapshot. But if the outage happens like 59 minutes and 59 seconds before the next snapshot, then you're going to have basically an hour of data loss. Now, if you do the synchronous replication between sites, every write that comes into your primary site is going to be synchronously replicated to the other data center. And so architecturally, you would want to make sure that those data centers have kind of a low latency network connection. Like we typically recommend a maximum of 10 milliseconds round trip. And then it's kind of like a high availability scenario in a local environment, which is where you can suffer one server outage because you have a replica on another server. This is the same idea because we're stretching a Portworx cluster across those data center boundaries, but the data is still replicated synchronously. RTO comes in and basically how quickly can I bring my application back up? And this is really, it's a function of like, is everything that you need staged in the other data center? That includes data, right? We've already talked about how that's a function of, your snapshot or your synchronous replication, but then also your configuration, your pods already is are your pods up and running, right? Or do you have to like pull them down from the public Docker registry once you've detected an outage? Those are things that are going to contribute to your RTO being longer. And really it's a cost benefit analysis that you go through, which is to say, like if I say RPO of 5 minutes, then there's a cost associated to you from an infrastructure perspective in meeting that SLA. You say an RTO of an hour, then there's a difference associated. And I think the key point that I made earlier in the talk is that Portworx gives you the ability to make that decision on an app by app basis. In fact, you as the Kubernetes architect, platform architect, right, really are not the one who's best capable of making that decision to begin with because you don't have the business requirements. And so your customers, the Kubernetes developers, are the ones that are closest to the business and can make that determination. So I hope that answers your question. If not, please type back in and we'll try to do a better job answering. A couple of other questions that I'll just read out so everybody gets the benefit. One was, what was the backend storage of the configuration? And it was EBS on Amazon. So we work with all of the Portworx is completely infrastructure agnostic. I covered that in the initial slides. So on Amazon, we can use EBS, and that's the most common, but we could also use Instance Store. So if you have like an EC2 instance with an ephemeral disk, but that's going to give you the cheapest high IO connection, then we can do that, and we handle replication. So even if that EC2 instance gets rebooted, like your data is still protected, really it doesn't matter. We will consume whatever raw block devices we see on a particular host, and if that's an EBS volume, we'll use that. If it's a local NVMe, we'll use that. If it's an enterprise array, like a LUN coming off a flash array, or an EMC box or whatever, we'll use that as well. And there was a similar question, actually, about someone doing a POC with Portworx, and they're doing it on Hyper-V, and we're asking if the VHDX drive will work. And my answer there is yes, for exactly the same reason that EBS works, because Portworx, we just see block devices that are attached to hosts. And it doesn't matter if it's like your local machine or an Amazon Outpost or a Google PD and a flash array from Pure. We can consume whatever storage is available to your Kubernetes cluster. Another person asked about is there a lab for kind of doing a hands-on demo, and so I pointed them to our to sign up for a free Portworx account on portworx.com. Just go to portworx.com and click the big button that says free. That will create an account for you, and in Portworx Central, which is our user interface, you can click on I think it's labs or hands-on or demo or something, I forget exactly the word, and it's going to bring you to a series of labs that'll allow you basically to do a lot of the things that Bhavin showed today. It's a virtual environment, but you don't have to provision any infrastructure to use it, and you can get it's the goal really there is to get familiar with using Portworx. If you want to do a deeper demo, then I would engage, or like really more of a true POC where you're completely in control of the environment. I would recommend that you work with your Portworx account team. Basically, just send us a contact form on our website. We'll get you in touch with the right people, and they can help you walk through a proper POC. Well, how about you take this next one, Bhavin? So another question about DR. Would it be possible to restore a PVC snapshot on the DR site rather than restore all the applications in DR? So just the PVC, but not all of the configuration, I think.
Yeah, so we can definitely do that. So in the YAML file that I showed, right, we had a parameter that included that was include resources, yes. So that was for the application piece. If you make that true, make that false, it will only copy over the persistent volumes, and then you can bring that up on the other side. Looks like this might also be a use case for PX backup, where you want to just move data over, not application components. So yeah, Portworx can definitely work there.
Awesome, great. Just looking through and typing in those answers for my records. Okay, what else? Well, we went through them all.
Yeah.
Talked about that one, talked about that one. So let's keep the questions coming, people. We really want to make this as efficient use of your time as possible. While you are typing in your questions, I'm gonna flash a slide to let you know how you can get started. So if I do this,
sorry, I might have to make you the presenter again.
Oh yeah, that's what it is.
Okay, you should be the presenter now, Michael.
Okay, great. Yeah, great.
Okay.
Yep, so so as folks put in their final questions, if you want to get started with Portworx, it's really easy.
Michael, I'm sorry, I see like a cropped out version of the slide. I don't see the whole slide.
Weird. Let's see. What about now?
Still the same.
Still cropped. Okay. Well, I'm just going to show it in preview mode. Hopefully, it's not too small to read. Let me see if I can just maximize the screen a little bit bigger. So you can kind of do three things. So one is we have a freemium product called Portworx Essentials. You can go do the exact same thing I just mentioned before, go to our website, click on try Portworx for free, sign up, and Portworx Essentials is a version of Portworx that will work for small applications, even if they're running in production. I mean, it's the same software that our enterprise customers use. Just some of the capabilities are designed for smaller applications, not larger applications. If that doesn't meet your needs, then you can do a free 30-day free trial, free 30-day free trial, free double free of Portworx Enterprise. And this will allow you to really test everything. And someone was talking about doing a POC. We would love to help you with that. Really get you really quickly to the point of knowing whether or not Portworx is something that can add value in your environment. And we also have the same option for PX backup, which is our backup and recovery solution. What Bhavin demoed today with PXDR is part of our enterprise platform. You can also use PX backup as part of our enterprise platform, but then you can also buy backup as a standalone product. So if you're, for instance, running an AWS and you're storing all of your Kubernetes data on EBS and not using the Portworx layer on top, then that's fine. We can still protect it, we can still back it up, we can still migrate it using our PX backup solution. So,
Michael, sorry, we were still seeing like the left side of the slide in this view as well. Like if you can just scroll to the right, we don't see the links now.
That's so weird. I can't. I'm fully maxed out on my screen. Hold on, let me just stop sharing and try to reshare. Thanks for letting me know.
Yeah, if it doesn't work, I can share it as well.
There we go.
Yeah, perfect. This works.
Okay, so I'm just going to leave, now I'm going to risk it and go into present mode so it's even bigger. Okay, good.
That's perfect.
Okay, and a couple of questions came in while I was stalling, so thank you for that. So I'm just going to look at these. Yeah, this is a good question. So does the block storage devices need to be shared between the nodes? How does that work? So I think if I understand the question, the answer is no. So it's not, Portworx, it's not like an NFS server where that same NFS share is mounted to each of the hosts. With block storage, it's mounted very much to one particular host. Your EBS volume is mounted to an EC2 instance, not to every EC2 instance in the cluster. So for data protection, so if I have a Postgres volume that's served from an underlying EBS volume, and I want to make sure that if the EC2 instance that Postgres pod is running on fails, that I can fail it over to another EC2 instance that has a local copy of the data, right? That's stored on another EBS drive. Portworx does the replication, and we make it so that a local copy of that data is available on another host. We also support read-write mini workloads where you actually can have multiple hosts that are accessing the same volume that itself is served from only a single EBS drive. And we do all of kind of the networking magic to make sure that that data that's actually kind of locally available on one particular EBS drive is accessible from everywhere in the cluster. So hopefully that makes sense, Bob. Would you explain that a different way, or?
Nope, that's perfect.
Okay, great. All right, any other questions? Oh, got a couple more coming in. So do we have any IO rate bandwidth limiting for replication? I think so. We don't, as far as I know. Though in computer science, there's always a limit. Sometimes it's the speed of light. Haven't solved that yet, but generally speaking, right, how quickly you can replicate is going to be a function of your network more than it is a function of Portworx. And we can kind of help you answer more specific questions on that for your environment. How do I eval PXDR? Your slides point to the base product. So DR is part of enterprise. So go and create an enterprise trial, and you'll be able to use PXDR as part of that. Someone saying thank you. Our pleasure. I really appreciate it. This has been. I really appreciate all the questions from everybody. And hopefully this will give you some pointers to continue with your Portworx journey. We love working with customers, and try. You can use it for free. You can use it self-service. We have great documentation, but we love talking to people as well. So I would say, as you go down the journey, if you have questions, go to our website, and we have a contact us form. That'll go directly to our account executives and our sales engineers who can really help you get really, really deep into how Portworx can fit into your environment, and so that you can kind of see the whole breadth and scope of what we can do for you. So I appreciate that. And yes, my colleague Katerina is pointing out that you can go to portworx.com/request-a/demo, and I will show you what that is real quick. If you go here, you can fill out this form, and then we will be able to walk you through a POC test plan. We've done it, hundreds of times with customers, and we're happy to do it with you as well. Okay, well, thank you all. Really appreciate your time. One other question. Any plans for a sync demo? PXDR synchronous demo? Yes, and you can watch it right now because we're gonna Google Portworx sync DR YouTube, and I know that we have done this demo. So these are from Tech Field Day. That's the thing about, let's just go to YouTube, Portworx YouTube. It's not spelled correctly, but Google to the rescue. Okay, we don't need to see a verb ad for Verbo live on this very webinar. Okay, here we go. So, playlists. It is in here somewhere. Where is it? I think it's in here. Portworx overview videos. Lots of great content in here. Well, why am I not able to find this? How about this? We'll send you a. Oh, do you know where it is, Bobbin?
Yes, I found it. I'll put it on chat. 1 second.
Yeah, put it in the chat. There's actually a question. If you could just drop it in and share with all.
Okay. Yep.
Yeah. So great question. We're not planning on doing it on one of these over the next couple of months, but we would love to do a private demo just for you. So just fill out that contact us form, and you can have your own very SE give you a demo of that. You can also watch the video of that that Bob will share here in a second on the chat. Okay, thanks everyone. Have a great rest of your day. Thank you, Bobbin.
Thank you all. Thank you for your time. Bye.
Bye.